Hello my dears, very good morning to all. So in the last class we discussed about the armature reaction, and we clearly discussed about the commutation and how this armature reaction and commutation connects, and how can we eliminate this armature reaction as well as the commutation by using interpoles, right, by using compensating winding, etc. So these are the method to eliminate such type of bad events occurs in the DC machine. Now we are going to discuss about the new topic, that is nothing but characteristics of DC generator. Characteristics of DC generator. Okay. So characteristics means mainly three characteristics are there. First one is magnetic characteristics or magnetization characteristics, Cara, and second one is internal Cara, and third one is external Cara. So these are the three types of important characteristics in the DC generator. So let's see what is mean by internal Cara, or sorry, magnetization Cara. So magnetization Cara is nothing but plot between generated voltage versus the field current is called the magnetization Cara. So let's see what is magnetization Cara. Okay, I will explain that. And before that, what is internal Cara means Eg versus Ia, and external Cara means V versus IL. V is nothing but the terminal voltage, Eg is nothing but the generated EMF, correct? In terms of generator, it is the generated EMF, and IF is nothing but the field current, Ia is nothing but the armature current, IL is nothing but the load current. Okay, so let's discuss one by one. First one, magnetization Cara. Magnetization Cara. So it is nothing but between, what are the parameter in magnetization Cara? Eg versus IF, which is nothing but we have to derive, or we have to connect these two things, Eg and IF, how they are connected, that's all. That is the meaning of characteristics, my dears. That is the meaning of characteristics. Okay, Eg and IF, how they are connected. Okay, so we have the basic equation of generator as the generated EMF Eg is equal to, what is that, phi Zn by 60 into P by A. Am I correct? This P is constant, A is constant, 60 is constant, and this Z is also constant, correct? So we can say that Eg will be proportional to what, my dear? N phi. Am I correct? Eg will be proportional to N phi. Or I can say that, okay, or I can say that N will be proportional to okay, one more thing I can write, like Eg will be equal to N phi, or phi will be proportional to Eg by N, correct? Phi will be proportional to Eg by phi, Eg by N. Am I right? This, from this equation, phi will be proportional to what, my dear? Eg by N, correct? So phi proportional to Eg I can write like, correct? Phi proportional to Eg, my dear. Phi is nothing but the flux per pole. Am I correct? Phi is nothing but what, my dear? Flux per pole, correct? Flux per pole. So flux per pole is directly proportional to Eg, means this flux per pole is provided by what current? Field current. Am I correct? This flux per pole is provided by what? Field current. Because in a shunt generator, the shunt field provide field current provide the shunt field. In the case of a series motor, what? The series field winding provide the series field flux. So this phi proportional to Eg means, or I can say that this Eg proportional to IF. This Eg proportional to IF. Am I correct? So if you plot a graph between these two, Eg and IF, suppose Eg you taken in the y-axis and IF you taken in the x-axis, so this will be the graph. This is already you learned, right? How's easy? Open circuit characteristics now. Eg versus IF. So what happened means, up to certain position, up to certain portion, Eg and If will be what? Linear, according to this relation. Strictly it follows this relation, correct? Eg and If will be strictly following this proportionality. But what happened after some time, ideas? Sometime the curve what fluctuates from its linearity, right? The curve fluctuates from its linearity. What is the reason? Because if you increase the field current, more and more flux will be induced in the surrounding media of armature. But after beyond certain limit, the core of the stator as well as rotor gets saturated. And even if you increase in the field current, it will not affect any or nothing on that induced EMF, because the core is already got saturated. If you again increase in the field current, then what you do? If you already, your stomach is full, if you again eat more, what happened? You will vomit, right? You will vomit. It won't accepted by your body. Or if you take a glass of water, it is full now, again you pour some more water, what happened? The water will be move outward, right? The water will move away from the glass, right? Correct? That means that external adding of water will not affect any type of, or will not influence in any manner of that glass, correct? That externally added water will not influence in any manner of what? That glass, correct? That it will not induce anything. So even if you increasing the field current, but after some time the induced EMF will not increase, because the core got saturated. This point is called the saturation point. Saturation point. Am I correct, my dears? Am I correct? So that is all about the what? Magnetization current. Okay. So you have to remember one thing. This is very important, is that Eg and If will be proportional to certain limit. To up to saturation, this will valid, correct? This will be valid up to saturation. Am I correct? This will be valid up to saturation, and after that this is actually invalid. This is actually what, my dears? Invalid. Am I correct? Am I correct? So that's all about the magnetization current. Next you have to see the internal current, my dears. Internal current. Next you have to see the internal current. Next you have to see the internal current. So magnetization current I already finished, right? So next you have to see the internal current. So what is meant by internal current? It is the graph between Eg and Ia. That is nothing but we have to relate this Eg and Ia now. Okay, we have to relate this Eg and Ia now. Okay, what happened? Listen, my dears, listen. So we have the basic relationship of generator as Eg minus IARA, correct? Eg minus IARA equal to what? V. Eg minus IARA for a series generator, simply Eg minus Ia into R. Let's assume just Ia into R for series GC generator, where R is equal to what, my dear? Where R equal to armature resistance plus series resistance, correct? Okay, so Eg minus Ia into R will be equal to what? V. This is the terminal voltage equation for the DC series generator. For shunt, is it simply Eg minus Ia into Ra plus? There is no RC, right? So Eg minus Ia into R for, this is for series DC generator, correct? Series CD DC generator. So what happened if you increasing the load? If IL is the load current, so you know the thing here, Eg, generally this is R, my dear. This will consist of RA and RC. Okay, so this is nothing but our Ia, which is equal to IL. This is the terminal voltage. So if you increasing the load, means the load will absorb more current. So that what happened, my dears, if IL increases, IA also what increases. If IA increases, what happens here? Armature reaction effect will increase, correct? If load increasing, the cross magnetization effect of armature reaction will increase, and eventually it will decrease as the EG, correct? I already explained this. Eventually it will decrease as the induced EMF. So the relationship between EG and IA will be EG inversely proportional to what, my dear? IA. EG inversely proportional to IA. Am I correct? So if you plot a graph between this EG and IA, suppose this is EG and this is IA, the plot will be like this, inversely proportional. The plot will be like this, inversely proportional. This is called the internal Cara. Is it clear, my dears? Is it clear? Next we have to see external Cara. External Cara. External Cara, my dears. External Cara. What was that? V versus IL, correct? V versus IL is the external Cara. What is the meaning of external Cara? I already told you. What happens if IL, load current, increases? If load current increases, what, my dears? What, my dears? IA also increases, na? If load current increases, IA also increases, na? If IA increases, EG will be decreases, correct? If IA increases, EG will be decrease, of course. Or in other words, we can explain in another manner. EG minus IA into R equal to V, na? If IA increases, what happens? The terminal voltage directly decreases. V directly decreases. So the relationship between V and IL is, this is that. V and IL is in such a manner that V inversely proportional to 1 by IL. V inversely proportional to what, my dear? 1 by IL. Am I correct? Am I correct, my dears? Am I correct or not? V inversely proportional to 1 by IL. So again the graph between, what is that? IL and V will be like this, inversely proportional graph you will get. Am I correct? Okay, so that's all about the internal Cara. That's all about the internal Cara, my dears. So if you plot this in a single graph, this all characteristics, if you plot this in a single graph, that you already done in your laboratory, na? You already done this. You will remember this when I draw this. Okay. EG, comma V, IA, comma IL. Did you remember this, my dear? Yes, you remember this? So I can say from this graph that the generated voltage minus this armature resistance lobe or ohmic losses minus armature reaction curve equal to the terminal voltage, equal to the terminal voltage, and this is called the internal Cara. This is called the external characteristic, my dears. Because external is nothing but EG, V versus IL now, V versus directly. So this is only V and IL. That is called the external chara. If internal chara means it is something EG versus IA na, so this is EG and versus IA will be the internal chara. So definitely this will be V, so this will be definitely associated with the external characteristics. That is the way in which you can remember. Now you make confusion between these two, whether it is external or this is internal na. That for removing that confusion I will tell you a trick. This is V na, so something connected with V is nothing but the external characteristics. So that's how you can remember this characteristics. Okay my dear, did you get the idea? Did you get the idea? Okay. Next, characteristics of DC shunt generator. Shunt generator. Listen, my dears, listen. So we have the equation of induced EMF as 5Zn by 60 into P by A, correct? P by A. PA 60, N all are, N, sorry, Z not N, Z, PA 60 all are constant. So EG will be equal to, or EG will be proportional to 5 into N, correct? For shunt generator, my dear, for shunt generator, 5 equal to what, my dear? 5SH. Am I correct? 5 will be equal to what? 5SH. That 5SH can be provided by, or I can say that this 5HS increases when ISH increases. Am I correct? This ISH will be increased when RSH decreases. Am I correct, my dear? That means this is a diagram of a shunt generator, my dear. This is EG, this is shunt, this is the terminal voltage, my dears. So this is RSH and this is ISH. So this is nothing but the load current IL, this is nothing but IE. That means this is the rough diagram of shunt generator. What is the peculiarity here is that the 5SH will be increases when ISH increases, and which is increases when RHS decreases, correct? This 5SH will be a constant. For shunt generator, this 5HS will be simply V by RSH. It's always constant. Okay. So the factor which affecting the flux in this shunt path is nothing but what my dear? This RSH, correct? This RHS, correct? So this flux 5SH is inversely proportional to what? RSH. Am I correct? So if you decrease the RHS, or RHS should have a critical value of resistance beyond which you can't increase the RHS, because if RHS increases, this 5 will be decreases. To what extent this 5 can be decreased? No, certain limit na. Otherwise this EG will be, if 5 will be less means EG will be very low. So we can decrease our flux to certain limit so that there should be some RSH called RSH critical. So this always keep my dear, always keep RSH below RSH critical. RSH below RHS critical. That means always keep the value of this RSH below the critical value of resistance. That's all. Below the critical value of resistance. If you again increase the resistance beyond that critical value, then there will not be any EG. The machine will not work. The generator will not work. So we have to always keep in mind that we have to make the critical value of resistance, and always keep in your mind the value of the shunt field resistance, my dear. This is the shunt field resistance RHS. Its value will be always less than the critical field. Okay, critical value. Okay, so what will be its graph? For shunt generator, what will be its graph, my dear? EG versus V, or it will be IA versus IL. So this is the graph of what? Shunt generator, and this is his internal cara, this is his external cara. So first this is A and this is B and this is C. These values nothing but, my dear, rated cloud. Okay, that means what is the meaning of that? What is the meaning, my dear? What is the meaning? You can increase the value of IA. That means, again one more thing, if you increase the value of IA, that means if you increase the load, this always ISH will be always a constant. For shunt generator, this ISH will be always constant. So if you increase the value of this IA, correct na? Yes. If you increase the value of this IA, if you increase the value of this IL, this load will, if you increase the load means this IA will be increased. This IA will be increased. If you increase the load means if IA will be increased, this terminal voltage also increased, this phi-s is also increased, right? So this is the meaning. If you increase the load means, terminal value, I will explain once more. If you increase the load means the current demand of the output will be increased. That is the meaning of load in terms of generator. In terms of motor, my dear, load means the turning power you increased. That is the difficulty you made increased. The turning difficulty you made increased means it is the load of the motor. The current absorbing power you increased means it is the load of the generator bus. Okay, so if you increasing the load here, what happened? The current absorbing capability will increase. That means, suppose here it is a resistor, its resistance value is slowly decreasing. That is the meaning of increasing load. So the terminal voltage will fall. That is the meaning here. So if you increasing the load current, what happened? The terminal voltage fall. Okay, if you again increase the load current means what happened, my dear? It will be like to be an open circuited condition, short circuited condition. If you again increasing the load means the current can maximum here. Current will be maximum when it is short circuited. Current will be maximum when it is short circuited. Short circuited means nothing, my dear. Voltage will be zero. Bas kadam kali. Short circuit is nothing but the voltage will be zero. See the voltage will. There is nothing. Am I correct? So that's the concept of what? The external cara and internal cara. Okay, V versus IL is the external cara. Okay, so there should be certain voltage. If you again increasing the load current means the voltage fall, right? The voltage fall and it will become to zero for certain load current. So the 0 point is noted here, that not the maximum value. 0 means zero voltage means it is suddenly short circuited, and if it is suddenly short circuited means what happened, my dear? See, whenever it is increasing, this phi-s will be increases. Phi-hs will be increasing means what happened? Phi-hs will be increases mean what happened? RHS is continuously slowing down. RHS is continuously slowing down. So that is also one of the reason for this dip in the voltage. Okay, that also you can explain in that manner. Anyway, this is not deeply, we don't want this. Simply see, remember the diagram. Okay, my dear, what's up? And what is the characteristics of one word question and all, you may see a diagram like this, and you have to pick what is the for shunt generator bus. Okay, is it clear, my dear? Is it clear? That's all for condition. Okay. Next, characteristics of compound generator. This is very, very important. Okay. This graph is very, very important, my dears. Okay, draw the sphere, my dears. Draw the sphere. Just you have to remember this sphere. You don't want to study what is over compounded, level compounded, machine construction, what is working, and all you don't want to know. Okay. Okay. Okay, so from this graph you have to learn something. Regulation, a concept of regulation, my dears. Regulation. So regulation is nothing but, voltage regulation is nothing but no load voltage minus full load voltage by full load voltage into 100. That's percentage regulation. No load voltage minus full load voltage divided by full load voltage is the regulation in terms of, this is for the generator, and for motor is equal to EV minus VT divided by VT into 100 for motor. So percentage of voltage relation is nothing but, my dear, what is the no load voltage minus full load voltage divided by full load voltage bus. So here the no load voltage is nothing but the maximum voltage obtained in any DC generator, whether it be compound, whether it be series, whether it is shunt, anything. The maximum value of voltage you obtained under no load condition only. That's very, very important, my dear. So that no load voltage is nothing but EG. Okay. And what happened if you increasing the load? If you increasing the load, if the voltage is increasing than EG, it is called the over compound generation. So for over compound, V greater than EG, my dear. Working and all we don't want. We just remember this thing. For over compound, V greater than EG. For under compound, my dear, V less than EG. V less than EG. Okay, for level compound, my dear, V equal to EG. V equal to EG. That's all. So for observing, by observing these graphs, we observe one thing, that the excellent regulation, the voltage regulation is offered by shunt generator. That means the points, main points here is that, excellent regulation is offered by what my dear? Shunt generator. shunt generator. That means there is no abrupt change between the EG and the terminal voltage. That means the slope is not that much, right? The slope is not that much when compared to this one. This is level compound, means it's an ideal case, but that too exists for only a very high load condition. In certain load, midway load, no, half load and all, what happen means it is again the regulation is poor. So what you have to make sure that the difference between these two will be minimum, then only we can say that it is a very good system. It is a very good generator. When the difference between these two will be minimum. For ideal case, these two are equal, it will be 0. For ideal case, my dear, for ideal case. This V equal to 0 for low loads, my dear, low loads. Okay, that you have to mention. So the difference between these two are minimum for what type? DC generator, for shunt type DC generator. All other having no very abrupt changes are there, but this is only where the change will be very small, so that is called the DC shunt generator. So we can say that excellent regulation will be offered by shunt generator. But see one person here, that person is nothing but differentially compound generator. See its nature, its voltage regulation is very poor. So poorest voltage regulation is offered by what, my dear? Differentially compound generator. This is very important. We make it in a box. Definitely this will be directly asked for your examination. This will be directly asked for your examination, my dears. So please remember this. Okay, so best voltage regulation is always given by the shunt generator, and poorest voltage regulation is always given by the differentially compound generator. Always keep it in your, fix it in your mind always. Okay, so can I rub this? And one more thing, my dears, the examination date is regarding some examination, Kerala PSC or no, or any state JEE examinations, no. Please mention in your comment box if any new vacancy come, no, any new examination date come. Please mention in your comment box so that everyone can see now. Everyone see. Suppose a new notification came regarding Kerala PSC or some other states. If you are eligible, then please mention it in the comment box. Okay, if someone can use now, if the news regarding job, share to everyone. Suppose if it is not if it is not useful to you, but many others are there, maybe they don't know because of the media exposure and all, they don't that much media exposure like Telegram, like WhatsApp or something like that, no, like employment news and etc. So if you share something related to job, means if someone is there in our country now, they also get benefited, right? So please share any news regarding employment, job, no, please share it in the comment section, no, that date comment section. You may comment in your comment section, okay? So that everyone can, our family members can know now. That's why. Write a question, my dear. Write a question. A 4-pole DC generator is running. At 1500 rpm. The frequency of current in the armature conductor is It's a very good question, and there is a chance of making error also. A 4-pole DC generator is running at 1500 rpm, my dear. So N is nothing but what is that? 1500 rpm. Okay, it's given. The frequency of the current in the armature conductor is, what will be the answer? What will be the answer? Okay, and poles are again as P is equal to what? 4 pole, right? There are many students are there, no, not many students, almost 80% of the students will directly go for the concept of induction motor and take the advantage of slip, and you may get it to some other answer, and there is in option also that answer. You will simply tick and you will come, you think that okay, hooray, it's already done, okay, I have done that question. It's wrong actually. Don't compare this with the induction machine. Don't compare this with the induction machine, my dears. Okay, so this is always keep in your mind that this is a DC generator. The purpose of the DC generator, I mean the working of the DC generator is nothing but there are two magnets which is also temporarily magnetized by some field coils. There are armature in which armature conductors are there, my dear. There will be what? Conductors inserted. So if the conductor is rotating with some speed, with the speed is 1500 rpm, if the conductor is rotating, there will be an induced EMF. There is no advantage of slip and or there is no need to consider the slip because it's not the induction motor, it is an induction, I mean it's a DC generator. You don't compare with the induction motor or induction generator. Clear? It is actually a doubly excited machine. A DC generator or a DC machine is a doubly excited machine because we use two sources for the working. One is for field, other is for armature. If it is a motor, if it is a motor. In the case of induction motor, it is a singly fed machine because we just give supply to the stator only. The rotor automatically come to rotate by the mutual induction action. That is the difference between these two. So if you consider for this doubly excited machine, such type of doubly excited machine, just go for the basic equation of what is we have to find? The frequency of the current, right? F is equal to Pn by 120. 4 into 1500 divided by 50, correct? 50 hertz will be the answer. 50 hertz will be the answer. Is it clear, my dears? The problem is clear with you? Problem is clear? Okay. Write another question. A 4-pole lap wound DC shunt generator has an armature winding consist of consist of 220 turns, comma, each of 0.04 ohm. Each of 0.02 ohm, okay? The armature effective resistance what? Listen my dears, a 4-pole lap wound, so I can write that 4-pole P is equal to 4, lap wound 4, A is equal to 4, that all. For lap wound DC and it has an armature winding consist of 220 turns my dear. That means there are 220 armature turns, 220 turns. Each of 0.4 ohm, 0.04 ohm means single turn. A turn means, like, suppose it's a wave winding, means this is a turn. These two conductor constitute the turn. Okay, so there are what? There are what, my dear? There are these like 220 turns are there. 220 turns are there and all are connected in series. Of course, we know that. All are connected in series. So, because all the turns are connected now, all the turns are connected, correct? Starting end of the one coil is connected to finishing end of the other coil, so it is connected in series. So the total resistance of the each coil will be, so total resistance will be what? Total resistance of 220 turns will be equal to, what is that, my dear? 220 into 0.04. Or I can say like this, 220 into 4 by 100, correct? 10 and 10 can cancel. It's 5, this is 11, 44 by 5. 44 by 5 means you will get like 0.88. Okay, 0.88. So this is the resistance of what, my dear? Total turn. Okay, total turn resistance is that 0.88. Okay, then since it is a lap wound generator, how many parallel paths it have? 4 parallel paths it have, correct? That means some bundle of conductors are connected in series, make it form one parallel path. Another bundle of conductors are connected in again series, another to make another parallel path, again another and again another. So the total 220 turns now, my dear, total 220 turns are connected by 4 parallel paths. So what is the resistance of each parallel path? What is the resistance of each parallel path? 0.88 by 4 na? 0.22, correct? So see, total you have 0.88 ohm is there. You have to equally split it into 4 parallel path, means you can take like each winding consists of 0.22 ohm. Am I correct? 0.22 ohm resistance will be constituted for one bundle of conductor. Again 0.22 for another, 0.22 for another, again 0.22 for another. So that everything will be sum up to 0.88. Am I correct? Did you get the concept, my dear? Did you get the concept? I will say once again. You have 220 turns. You have 220 turns in your hand. 220 turns means such a 220 turns are there, correct? 220 turns are there. Each of 0.04 ohm means each turn will contain 0.04 ohm resistance. So what will be the total resistance in your hand? 0.88 ohm resistance is in my hand. Okay, you have to split this 0.88 for resistance, 884 into 4 group. Then each group contain how many resistors? How many? Each group, my dear, each group, not this is the parallel path, okay, in which so many conductors are connected in series and having a certain resistance. This resistance is nothing but what? 0.22. Am I correct? This resistance is connected in 0.22, contain the resistance of 0.22, okay. You have, I will explain. You have 500 turns, my dear. You have, suppose you have 500 turns. The resistance is 100 ohm. Okay, resistance is 100 ohm. Total resistance is 100 ohm. You have 500 turns. Total resistance is 500 ohm. 500 ohm. You have to make it into 4 group. You have to make it into 4 group, equal group. Then that equal group will contain what resistance? You have 500, total 500 turns. For 500 turns, my dear, 100 ohm is the resistance. Okay, so suppose you have to make it 5 turns. Suppose you have to make it 5 turns. Each turn will contain what? How many resistors? How many resistors? 500 turns, 100 ohm resistor you have. Okay, so suppose you have to split it into 5 turns. For 500 turns, 100 ohm. So one turn is 1 ohm. So if you have to equally split this 100 ohm to this 500, okay, it's again confusing. Don't worry. Come to the question itself. Not go for other question. Total resistance of 220 turns is nothing but, my dear, 0.88. Okay. You have to make it into 4 parallel path here. That means you have to take equally 4 bunches. Then of course each bunch will contain 0.22 ohm na, 0.22 ohm na, because total you have 0.80. That means from here to that end you have 0.88. In between you have to break to 4 sessions. Then each session will contain what, my dears? Each session will contain 0.22 ohm. That means this is 0.22, this is 0.22, this is 0.22, this is 0.22. Am I correct? See the nature of the parallel path. These all parallel paths are connected in parallel now, my dears. These all are connected in parallel. So what will be the effective armature reaction felt by someone who is standing here? This 0.22, 0.22, 0.22 all are in parallel. There you can apply the concept of parallel, not before. That's very, very important. Not initially itself you can't apply the principle of parallelism. You have 220 turns, my dear. So from here to that end you have 220 turns. From here to that end you have 0.88 ohm. I want to split it by 4 sessions. So each session contains 0.22 ohm. And I got this 0.22, this 0.22, this 0.22, this 0.22. Finally I have to connect all in parallel. So the effective resistance will be what, my dear? Effective resistance will be effective resistance will be, resistance means armature resistance, equal to, or Ra equal to 0.22 by 4, because all are connected in parallel. So divided by 4 will give you the effective value. So the answer will be 0.22 by 4 means 0.055. So that is the final answer, my dear. 0.055 is the final answer. Did you get the idea? Did you get the idea? Did you get the idea, my dears? What's the time now? What is the time now? Okay. Did you get the idea? Can we move to next question? In different manner you can solve it in other manner. Sorry, 220 turns means Z is equal to 2T. You can take in that way also. 2T. So total number of conductors you will get like 440 conductors are there. So you have to make this 440 conductors like 4 bundle. So each bundle contain what? 440 by 4. 110 conductors. 110 conductor, right? Each turn contain 0.04 ohm means one conductor will be 0.02 ohm, correct? So 110 conductor will be 110 into 0.02. That will be the total. And these again connected in parallel. That also you can, in that way also you can solve. Okay. Anyway you can solve. Anyway you can solve. This is a tricky question, my dear. There is a chance of error. There is a chance of error. Very, very tricky question. Always keep in your mind. Because in the option there is that one answer like 0.22 also will be there. So you suddenly go for 0.22, that's why. At certain speed and flux, at a certain speed and flux, the voltage generated by a DC generator is is 230 volt. If the speed is increases by increases by 20% and flux is reduced by 10%, the voltage will be, or the generated voltage will be, how can we solve, my dears? A certain speed, at a certain speed and flux, the voltage generated by a DC generator is 230 volt. If the speed is increased by 20% and flux is reduced by 10%, at the instant itself there is a change of flux happens, means it is not a DC shunt generator. That first thing you have to keep in your mind. If the flux is changing, means not a DC shunt generator. It may be anything. It may be a compound generator, or it may be what? A series generator, level compound, anything you can assume, but never assume for DC shunt generator there, because it's flux constant. Here its flux is not constant, it's changing. So we can't take for the DC shunt generator here. So you can directly take any other machine. Okay. So if the speed is increased by 20 and the flux is reduced by 10%, the generated voltage will be, that's we have to find, my dear. So we have, my dear, Eg will be equal to again 5Zn by 60 into Z by A. 5Zn by 60 into P by A. Okay. If you know this relation, 30% of DC machine you learned, if you just know this equation. You can play with this equation many times. Many questions you can play with this equation. Okay. So from this, P is a constant, A is a constant, Z is a constant. So you can say that Eg proportional to phi n. Correct? Eg proportional to phi n. Okay. So let Eg1 proportional to phi 1 n1 at certain field. And you can take for this Eg proportional to Eg1 proportional to phi 1 n1. So at a certain speed and flux, the voltage generated by a DC generator is 230. So it is given as 230. So I can write like, it will be Eg1 proportional to phi 1 n1. Next let be Eg2 happens. Next Eg2 we want to find. The speed is increased by 20% means what, my dear? This n1 is increased by 20% means, what is the meaning of that? What is the meaning of that? What is the meaning of that? 120 by 100 na into n1. That is the meaning of speed is increased by 20% and the flux is reduced by 10% means 90 by 100 into phi 1. Am I correct, my dear? In the next case, what we changed, the speed you increased by 20% means 120 by 100 into n1. Flux reduced by 10% means only 90% flux will be there. So 90 into phi 1 by 100. Okay. So again you can take like this one, you can take 12 into 10. What, my dear? 12 into 9. 108. Correct? 10 into 10, 100 into n1 5. Again this is nothing but, my dear, what is n1 phi 1? n1 phi 1 proportional to what, my dear? Eg1. Correct? n1 phi 1 correct corresponding to Eg1. Okay. Or you can say like this, no issue, no issue. So this is Eg2 now. This is Eg2. So this is Eg1. This is, let be equation number 1. Let be equation number 2. Okay. So what is 1 by 2? Eg, or 2 by 1. What is 2 by 1? Eg2 by Eg1 will be equal to, what is my dear? By, if I would cancel, Eg2 will be equal to, this 108 by 100 means, I can say like in percentage wise, in percentage, I can say that Eg2 will be equal to 8% increase of G1. Am I correct, my dear? Am I correct? Eg2 will be 8% zyada, I mean more than Eg1, I can say na. So this will be the answer. Eg2 equal to 8% more than Eg1. That's all of the answer. That's all about the answer, my dear. So Eg2 will be increased by 8%. Did you get the idea? Did you get the idea, my dears? Okay, so that's all for today's session. Let's meet again tomorrow with a new session. So until then, bye.